Hello, my name is Fatih Furkan. In this video, we built a SageMaker pipeline to train and deploy a BERT based base text classifier. Introduction. In this lab, we will do the following: define and run a pipeline causing a directed acyclic graph, which is DAG, with specific pipeline parameters and model hyperparameters. Define a processing step that cleans, balances, transforms, and splits our dataset into train, validation, and test dataset. Define a training step that trains the model using the train and validation dataset. Define a register model that creates model package from the trained model. Define a conditional step that checks the model's performance and conditionally registers for the model deployment. Terminology. Pipelines, a directed acyclic graph of steps and conditions to orchestrate SageMaker jobs and resource creation. Processing job steps, a simplified managed experience on SageMaker to run data processing workloads such as feature engineering, data validation, model evaluation, and model explainability. Training job step, an iterative process that teaches model to make predictions on a new data by presenting examples from a training dataset. Conditional step execution provides conditional execution of branches in a pipeline. Registering models, register a model in a model registry to create a deployable models in Amazon SageMaker. Parameterized pipeline executions allows pipeline executions to vary by supplied parameters, model endpoint. Host the model as a REST endpoint to serve predictions from a new data. BERT pipeline. The pipeline that you will create follows a typical machine learning application pattern of processing, training, evaluation, and model registration. In processing step, you will perform feature engineering, transform, review, underscore body text into BERT embeddings using the pre-trained BERT model and split the dataset into train, validation, and test files. The transformed dataset is stored in a feature store. To optimize for TensorFlow training, the transformed dataset files are saved using the TF record format in Amazon S3. In the training step, you will fine-tune the BERT model, the customer reviews dataset, and add a new classification layer to predict the sentiment for a given review body. In the evaluation step, you will take the trained model and a test dataset as input and produce a JSON file containing classification evaluation metrics. In condition step, you will register the trained model if the accuracy of model as determined by our evaluation step exceeds a given threshold value. First, we install the required models. I'll ignore the warning messages during the installation. So I'm going to stop the video here. Okay, it's finished. So we import the libraries here and we set up the pipeline name as BERT pipeline and format timestamp. From now we configure the dataset and processing step. Configure the S3 path for raw input data. The raw dataset in the public S3 bucket. Let's start by specifying S3 location of it and list the files in the S3 buckets. In this case it will be just one file, as we can see, one CSV file. configure the processing step. For the pipeline workflow, we will need to create workflow parameters of a specific type, integer, string, or float. Now set the parameters for the processing step, and let's set the parameters as written here. Setting up scikit-learn based processor, pass the SageMaker execution role, processing instance type and instance count. From SageMaker we import scikit-learn processor, and now we will use the processor instance to construct a processing step along with the input and output channels and the code that will be executed when the pipeline invokes pipeline execution. This is very similar to a processor instance run method. For those familiar with the existing Python SDK, note the sentiment train and sentiment validation and sentiment test named channels specified in the output configuration for the processing job. Such step properties can be used in subsequent steps and will resolve to their runtime values at execution. In particular, we will call out this usage defining the training step. So processing step, name processing, and step type is step type and processing. Now we can call out the properties of the processing job as an object using the command processing step properties to print out the explore attributes with dict method. Pull the channel sentiment train from the output configuration of the processing job. Print out the attributes of the resulting object. So here app managed feature store output, output name, S3 output, path, and shape name. Now we can pull and print out the attributes of the S3 output path related to sentiment train output channel. In here we have exercise 1 and pull and print out the attributes of the S3 output path object related to sentiment test output channel. Use the example cell in above. So we should use this code. Like that. Let's run it. Okay, I have a problem here. We can fix it like that. And these objects can be passed into the next step of the workflow. Also, we can pull the arguments of the processing step with the corresponding function. The results in the dictionary format. Revive the case of this dictionary. The dictionary case are processing resources, app specification, role arn, processing inputs, processing output config, and environment, processing step arguments, processing inputs. And here we have exercise 2. Pull and revive configuration of the processing outputs from the arguments of the processing step instructions. Find the required key in the arguments dictionary and pull the corresponding value following example above from here. Let me check it real quick. Okay, so we should processing output config. We should use that to check processing outputs. Let's use that and Let's use that like that. And as we can see, we pull and revive the configuration of the processing outputs. And here, configure training step, define parameters, set up parameters for the workflow. As you can see here, the parameters. Configure the hyperparameters, set up the dictionary that will be passed into hyperparameters argument. And after configuring hyperparameters, configure model evaluation matrix. Choose loss and accuracy as the evaluation matrix, as we can see here. For example, these sample log lines will produce following matrix in CloudWatch. Loss is 0.55 and accuracy 74.64. And configure the PyTorch estimator. Configure an estimator and input dataset. A typical training script loads data from input channels, configures the training hyperparameters, train a model, and saves the model dir so that it can be hosted later. From SageMaker PyTorch, we import PyTorch as PyTorch estimator, and we define estimator here and set up pipeline step caching. Step signature caching allows SageMaker pipelines before executing a step to find the previous execution of a step that was called using the same arguments. Cache it gets created if the previous execution is found. Then during execution, instead of recomputing the step, pipelines propagates the values from cache it. Timeout period is defined using ISO 8601 format. It can contain a year, month, week, day, hour, and minute value. More details on SageMaker Pipeline step caching can be found here in this link, showing here. And we import cache config from SageMaker workflow steps and define a cache config, enable caching true, and expire after PT1H, which is represent 1 hour. Configure the training step. Now configure the training step calling the outputs of the processing step. We import training input from SageMaker inputs and training step from SageMaker workflow steps, and define the training step here, main inputs and train validation, and print the training step. In here, use dict method to print out attributes of the training step properties. Briefly view the result. The attributes match the object of the describe training shop response object. Okay, let's use dict method. And let's run it. Configure model evaluation step. First, develop an evaluation script that will be specified in the model evaluation processing step. The evaluation script uses the trained model and the trained test dataset to produce a JSON file with classification evaluation metrics such as accuracy. After pipeline execution, you will examine the resulting evaluation JSON file for analyzing. The evaluation script performs the following steps: loads in the model, reads in the data, reads in the test data, issues a bunch of predictions against the test data, builds a classification report including accuracy, saves the evaluation reports to the evaluation directory, create an instance of the sklearn processor to run our evaluation script as scikit-learn based SageMaker processing job. We import sklearn processor from SageMaker sklearn processing and evaluation processor defined here. sklearn processor from version and role etc. in here. Set up the property file. We import property file from SageMaker workflow properties. Use the processor instance to construct a processing step along with the input and output channels and the code that will be executed when the pipeline invokes pipeline execution. This is very similar to processor instance run method. And let's run the cell. Configure and register model step. Configure the model for deployment. Use the estimator instance that was used to training step to construct an instance of register model. The result of execute and register model in a pipeline is a model package. A model package is reusable model artifacts abstraction that packages all ingredients necessary for inference. Primarily, it contains of an inference specification that defines the inference image to use along with an optional model weights location. A model package group is a collection of model packages. You can create a model package group for a specific machine learning business problem, and you can keep adding versions model packages into it. Typically, customers are expected to create a model package group for a SageMaker workflow pipeline so that they can keep adding versions model package to the group for every workflow pipeline run. The construction of register model is very similar to an estimator instance register method. For those familiar with existing Python SDK, in particular, you will pass in the S3 model artifacts from the training step properties. Of note, here you will be provided a specific model package group name which will be used in the model registry and continuous integration continuous deployment CI/CD work later on. Let's set up the variables. We define model approval status and deploy instance type, deploy instance count, and model package group name BERT revives. Let's print that. Configure the model metrics to be stored as metadata. Define deployment image for inference. We register the model for deployment. Exercise 4. Configure the register model step. Instructions. Pass the inference image defined above into image URI argument of the function register model. Revive the rest of the arguments. So here we use inference image URI. Let's run the cell. Create a model for deployment step. Let me check that exercise. Again, we configure model for deployment. Pass the same inference image into image URI argument of the model function. Let's write it again. Image underscore inference underscore image underscore URI. Okay, let's run this cell too. Now configure create model input. Import create model inputs from SageMaker inputs, create inputs, and create model input. And configure create model step for the workflow. Pass defined above model and model inputs configuration into the related arguments of the function create model step. Let me check it real quick. So we use model as model and inputs as create inputs. Yeah, create inputs and model as model. Let's run this cell. Check accuracy condition step. Finally, you would like to only register this model if the accuracy of the model as determined by our evaluation step exceeded some value. A condition step allows for pipelines to support conditional execution in the pipeline deck based on condition of the step properties. Below, you will define a minimum accuracy value as a parameter. Define a condition greater than on the accuracy value found in the output of the evaluation step. Use the condition in the list of conditions, condition step. Pass the register model step collection into the if steps of the condition step. Let's run this and we can use default value as shown in here. And let's run this out to 7. Create a pipeline. Define a pipeline of parameters, steps, and conditions. Let's tie it all up to a workflow pipeline so you can execute it and even schedule it. A pipeline requires a name, parameters, and steps. Names must be unique with an account region pair so you can append the time step to the name to reduce the chance of the name conflict. Not all the parameters used in the definitions must be present. Steps passed into pipeline need to be in the order of execution. The SageMaker workflow service will resolve the data dependency deck as steps the execution complete. Step must be unique to either pipeline step list or single condition step if else lists. So let's examine the JSON of the pipeline definition that meets the SageMaker workflow pipeline DSL specification. By examining the definition, you are also confirming that the pipeline was well defined and that the parameters and step properties resolve correctly. You can see here the pipeline parameters. Let's run this up. Ignore the warning below. Create pipeline using create method and then print the Amazon resource name IRN of it. We can see the IRN here. And let's check the SageMaker pipelines. We can see BERT pipeline created on 23 seconds ago, and if we enter inside of it, we can see the parameters here, and we can see information. IRN number is here, and we can see that number is matching with that. And here we have the pipeline graph here. After we running the code, we can see the processing is running. Okay, let's okay, it's given an error because we already created the pipeline, so I made a mistake by running it again. Let's continue. Start pipeline. Let's submit our pipeline definition to the Amazon SageMaker Pipeline service. The role based in will be used by the service to create all jobs defined in the steps. You will start the pipeline using parameters passed into start function. You can see here pipeline start. We pass those parameters and start the parameter, start the pipeline, and wait for pipeline execution. Now you can describe execution instance and list the steps in the execution to find out more about the execution. You can see here executing, and I will pause the video here after that processing is end. I will continue. So let me pause the video here. Okay, now it's succeeded. Let's continue and print the execution display name and its IRN. Describe the completed pipeline. Wait for the first step to start running and print the information about it. As you can see, all steps are succeeded. Wait for the pipeline to complete. To get the information about the pipeline execution, you can use low-level service client of the Boto 3 session. It's the Boto session. It's also useful for other operations that you will see below. In this code, you will be observing pipeline execution summary, and for the execution status, change executing to succeed. Let's run it. It succeeds because we waited before the running that cell. Let's run this cell. Evaluate the model. Describe the evaluation matrix. Examine the resulting model evaluation after the pipeline completes. Download the resulting evaluation JSON file from S3 and print the report. Exercise 7. Pull the name of the model evaluation and then get the S3 path of the evaluation matrix stat, which will contain evaluation report. So evaluate model. Find the execution step with the step name. Let's run this cell too. Review and evaluation reports. Download the evaluation report and print the accuracy. Here we can see this is the accuracy. List the pipeline artifacts. Find and print IRN job. Let's train and run that cell. Using similar approach, you can find and print pipeline artifacts. As you can see, deploy and test model, approve trained model. The pipeline create model package person within the specified model package group and approve status of pending manual approval. This requires a separate step to manually approve the model before deploying to production. You can approve the model using SageMaker Studio UI programmatically as shown below. Get the model package IAM and update the model package with the approved status prepared for deployment. The model must be approved before it can be deployed. Let's deploy the model. Get the model ARN and the model name from it. Create endpoint from registry. Configure the endpoint. Create the endpoint. And wait until the endpoint is deployed. Okay, let's run the cell 2. Let's pause the video here. Okay, the code is executed and endpoint deployed. We test the model, predict the sentiment with revive body samples and revive the result. And Sage, we predict class with probability 0.94, predict class 0 with probability 0.52, and predicted class -1 with probability 0.74. SageMaker Studio extensions. SageMaker Studio provides a rich set of features to visually inspect SageMaker resource, including pipelines, training jobs, and endpoints. Please take time to explore it, opening the face shown in the following image. Congratulations, you have just deployed end-to-end pipeline with BERT and SageMaker pipelines. Upload the notebook into S3 bucket for grading. Okay, let's upload. Okay, now we finished this assignment, so let's finish the video here. Thank you for watching. Have a nice day.